Hi everybody, it's Mr. Oaks, Fresh Cut. So today we're going to start talking about more high school level stuff, which is going to start actually off with multiplying binomials. Now, in high school you're going to learn about something called polynomials. And polynomials just means multi-termed expression. Poly meaning multi, nomials being terms. So you have different types of polynomials. First off, you have one that's just called a monomial, which actually isn't a polynomial because it only has one term. So something like 3, where that's it. That's a monomial because it's one term. 5x, even though you're saying two different things, because it's a product of a number and a variable, it's considered one term, so it's a monomial. A binomial has two terms, and that's what we're going to do today. We're going to multiply binomials, and our results are going to be trinomials. So binomials is two terms. So as we see here in this parenthesis, we have x plus 1. X is one term, 1 is the other term. A trinomial will wind up having 3 terms. Okay, so usually they're some type of variable term with a exponent that's greater than 1, another variable, the same variable usually, but now it has an exponent of 1, and then just a constant term, so just a number. So what we're going to do is we're going to multiply these binomials, and we're going to do two different ways. And the first way we're going to do is going to be something called the box method. Alright, the box method. And what that is we're actually going to kind of make a grid, a box, and we're going to use that to help us multiply these two terms. So we have these two binomials. So we have x plus 1 times x plus 1. So what we actually have here is we're going to be squaring a term. You'll learn more about that in a later video, but we're going to start off with this. So what I'm going to do is I'm going to draw a grid box, a 4-quadrant box. So, okay. And what I'm going to do is I'm going to take each of our binomials and I'm going to write one along the side and one either along the top or along the bottom. I've seen it done both ways, and really honestly it's more of a which one you prefer. Okay, so I'll probably switch between the two ways, you know, where it's on the top and on the bottom. But what we usually do is we take one term, and I'm going to start with the first, I keep saying term, sorry, the first binomial, and we're going to put it along the side. So the first term of that binomial, we're going to put next to the top box. So our first term is an x, so I'm going to put an x there. The second term, along with its sign, I'm going to put next to the bottom box. So plus 1. So next what I'm going to do is I'm going to take my second binomial, which in this case is also x plus 1, and I'm going to write it across either the top or the bottom. Again, it's really a preference thing. It's really something where it's what you feel you like better. It's an aesthetic thing. It's the way it looks. It's really just a preference of your own. I'm going to do it across the top. So first, above this first box, I'm going to write that x. And across over the second box along the top here, I'm going to write plus 1. Now what I'm going to do is, when I go to each box, I'm going to take the term that's to its left and the term that's above it, and I'm going to multiply those together. Now I'm going to do it the long way so you can see what I mean. So the first thing I'm going to do, I'm going to take this upper left-hand corner box here. I've got x on top, x on the left. So in here I'm doing x times x x squared. So we have something times itself is going to give us a squared term, which in this case, since it's just variables, we're going to write the squared there, x squared. I'm going to go across, okay, so I'm still going to stay with this x here on the left, and now I'm going to go to the plus 1 over here, and I'm going to multiply those two together. So I'm doing x times a positive 1, which we can write as 1x or just x. I'm going to write it as 1x for now. So 1x. Okay? So now I'm going to move down here where I have the positive 1, the plus 1. Above is an x. So again, I'm going to now write this as first 1 times x. And when we have a number times a variable, we just write the number in front of the variable. So 1x. Okay? Then I go to this last box here, and I have a plus 1 times a plus 1. So I have a positive 1 times a positive 1, which is going to be a positive 1. So now what I'm going to do is I'm going to write each of these boxes, each term that I now have because of these boxes, I'm going to write them next to each other. And if I have a positive term, I'm going to write a plus. If I have a negative term, I'm going to write a minus. So the first one doesn't matter unless it's a negative. But here I have x squared, so I write down x squared. I have a 1x, so plus 1x. I have another 1x, so plus 1x. And then I have this 1, so I have plus 1. So I've got my terms out. The next thing I'm going to do is I'm going to look and see, do I have any like terms? So I'm going to look. I have this x squared, no other x squared terms, so I'm going to write my x squared down. Next, when I look, I see I have this plus 1x, and I have another x term, which is plus 1x. So what I'm going to do is I'm going to combine the coefficients, 1 here and 1 here, and I'm going to combine them together. So I have here 1 plus 1 is 2, and then I'm just going to write the variable afterwards. Okay? Lastly, I've got this plus 1, and there's no other, just constants, so plus 1. And that's my answer, because since this x here has an exponent of 2, has a squared on it, I can't combine it with this x here. I can only combine like terms when they have the same variable with the same exponent. Otherwise, I cannot combine them. Okay? So as you see, we went from having 2 binomials to having 1 trinomial. Binomial, 2 terms. Trinomial, 1, 2, 3 terms. And what's important to remember is one of the things with knowing that something is a polynomial is that its exponent is not a fraction and not a decimal. So this is a polynomial because I have this 2, I have this only has a 1, and technically this would have an x with an exponent of 0. So all of them have non-fractional, non-decimal exponents. And that's basically what we do with the box method. So we're going to do 2 more of a little bit more increasing difficulty, not too difficult. Don't want to go too crazy here. So the first one I have x minus 1 times 3x plus 4. So now I have here, I have a number in front of this variable, so I have a coefficient that is not 1. And I'm just going to set it up the same way I did before. I'm going to take this x, put it next to this box, my -1, right there. Yep, you see it. Across the top, 3x is going to come first, and I'm going to put +4 over that next box. And then I'm going to multiply them. Now this time I'm not going to write out in the box what's multiplying, because we should know what's multiplying. So I have here x times 3x. So I have 1x here times 3x here. When I multiply the coefficients, 1 times 3 is going to be 3. X times x is going to give us x squared. So there's my first term. I go across now. X times a +4. Again, I have a number multiplying a variable. All I can do is put them right next to each other. So 4x. Here again, -1 times 3x. This one doesn't have a variable, but I'm going to multiply my constant here by my coefficient here. -1 times 3. It's going to give me a -3, and I just bring the variable down since it's the only one there. Lastly, the two constants. -1 times 4. A negative times a positive is going to be a negative. 1 times 4, 4. When I write these down, I'm going to see if I can fit it over here. I get 3x squared, not going to fit, plus 4x across the top. I got a -3x, I'm going to do it this way, -4. So you see across here, I've got 3x squared plus 4x. Along the bottom, I have -3x minus 4. You'll also notice that the two x terms are lined up. So when I look and I add these two things together, I have 3x squared, not adding anything, so 3x squared, 4x minus 3x. I have 4 x's, I take away 3 x's, I'm only going to have 1 x, which in this case I'm just going to write as x, no 1 in front of it. And then the -4, that's the only constant we have here. That's our answer. One more example there. This time I have two binomials where the variable term in both has a coefficient that is not 1. So, again, I'm going to write these. Now you'll notice I made my box go up pretty close here. So I really can't write across the top. So I'm going to write it across the bottom here. So the first one I'm going to do 4x plus 5. Again, my 4x next to my top left box, plus 5 next to my bottom left box. 3x, I don't want to jam it in here, it's not enough room. So this time I'm going to put it down here, alright, because out of necessity, I don't have enough room. So, 3x plus 3. So again, I'm going to multiply my 4x times my 3x, bring them together. 4 times 3 is 12. X times x is x squared. I go across. 4x times a +3. 4 times 3 is 12. We only got the 1x. Now go across the bottom. +5 times 3x. 5 times 3 is 15. Keep the x. 3 times 5 is 15. So again, like I did over here, I'm going to set them up across from each other. All right? So I have 12x squared plus 12x, oh, that's going to be kind of close. And I have 15x plus 15. I don't want to write on the wall. I add up. Nothing underneath the 12x squared. So I got 12x squared. 12x plus 15x. I've got 12 plus 15. Gives me 27. Bring the x down. 15 is the only constant. So plus 15. So I get 12x squared plus 27x plus 15. So that's how we use the box method to multiply two binomials. Now the other method, and the one that's mostly taught, and the one that's kind of pushed the most, is what's known as the FOIL method. And they have similarities and there's some differences. But for the most part, they're really basically the same. Alright, the one main difference in that box method, you make a box. In the FOIL method, first off, FOIL stands for first, outside, inside, last. Because what you're doing is you're multiplying the first term in each parentheses, then you're multiplying the outside terms looking at the parentheses, then you're doing the inside terms when you're looking left to right of the two parentheses, and then you're multiplying the last term from both parentheses. It's a little easier to tell when I actually do the multiplication. And one of the things that's also going to help is we kind of do really what the FOIL method is, and another math teacher, my friend Mr. Cornell, look up his stuff, he's got some good stuff there. Mr. Cornell, he refers to it as double distribution. So basically what we're going to do is we're going to do the distributive property twice for each thing, because we're going to distribute this x to both things in this parentheses, we're going to distribute this 5 to both things in this parentheses. So as you see, we have x plus 5 times x minus 10. So what I'm going to do, I'm going to grab a couple of different colors. And what I'm going to do is I'm going to take this x, and the first thing I'm going to do first, I'm going to multiply the two first terms in each parentheses. So I'm going to do x times x, which is going to give us x squared. So that's the first thing. Second thing we're going to do, the outside terms. So when we say the outside terms, we're referring to the x and we're referring to the negative 10. So I'm going to take this x and I'm going to distribute it to that negative 10. So x times negative 10, which is going to give us a negative 10x. Next, we're going to do the inside terms. The inside terms are the ones that are kind of like when you look left to right, they're in the middle. So I have this 5, and it's going to multiply the first x here. So we have 5 times x, which is going to give us 5x. And then lastly, we're going to multiply the last term in each parentheses. So the last term in the first parentheses is this 5. The last term in the second parentheses is the negative 10. So those two are going to multiply together. So we have 5 times negative 10. That's tough to see. And that gives us a negative Now again, what we have to look for is, do we have like terms? So I have this x squared here. I have no other squared terms, so I'm going to write x squared. But if I look, my outside and my inside terms are both x terms. Okay, both have the x variable. So, we're going to put these together. Alright, so we have negative 10x plus a positive 5x, or more negative, so it's going to be a negative. 10 minus 5 is 5, and we keep the x. So our middle term is going to be a negative 5x, and then our last term is the constant, is at minus 50. And that's what we do. So as you see, there's a lot of similarities. We still have to combine those middle terms, those x terms together, to make it go from having 1, 2, 3, 4 things to being our trinomial with 3 terms. Okay? So it's really just 2 different ways to organize our work. And that's really what most of this stuff is. It's how do I organize my work so it makes sense to me and anybody who's looking at my work. So I have 2 more problems and then we're done. Okay. So here, x plus 1 and 2x plus 2. So we're going to do these like this. So my first terms are x times 2x. So I have x times 2x there. And I'm always going to separate these with a plus. It's going to get a little crowded here. Plus, then we got the outside, the x times the 2. Inside, 1 times 2x. So 1 times 2x. And then plus, use a different green. The last is the 1 and the 2. 1 times 2. Okay? So when we look at these, x times 2x, 1 times 2 is going to be 2. X times x is x squared. Plus x times 2 is just going to be 2x. Plus 1 times 2x is just going to be 2x. Plus, lastly, 1 times 2 is 2. So, now what we're going to do is we're going to take these and we're going to write down, combining like terms. I look for another x squared term, nothing there. So, 2x squared comes down. But I got these 2 middle terms here, 2x plus 2x. 2 plus 2 is 4, so that's plus 4x. And then lastly, that plus 2 at the end. And that's how we get our answer there. And I'm just going to take this and move it up a little bit. Okay. So, last one here. 5x minus 3 times 3x plus 2. The method stays the same. I'm going to multiply my first terms. I'm going to multiply my outside terms. I'm going to multiply my inside terms, I'm going to multiply my last terms, and then when I combine everything, I'm going to combine my middle terms, my outside and inside, and now I'll have my trinomial on the end. So, look, first, five x times 3x plus outside 5x times 2 I get a rhythm one of these times. Plus inside negative 3 times 3x plus last negative 3 times 2. So 5x times 3x, 5 times 3 is 15. X times x is x squared. Plus 5x times 2 is 10x. Plus this is the one I'm going to do a little bit weird. Negative 3 times 3x is going to be a negative 9x. I say it's weird because I'm putting that in parentheses, but there's a reason. I don't want a minus, plus a minus. Then plus, I'm going to do a weird one again. Negative 3 times 2 is a negative 6. So, again, combine any like terms. 15x squared, it's the only x squared term, so I'm going to bring it down, 15x squared. Then I have these two middle terms that are both x terms, so I have 10x plus a negative 9x, which is pretty much 10 minus 9, which is 1, so 1x or just x. And then we have plus a negative 6, plus a negative is just subtraction, so minus 6. And that's how we do this. I hope this was helpful. I hope you found it helpful. If you did, please like and subscribe. I'm Italian, it's my hands. Alright, again, hope this was helpful. Like and subscribe. I'm Mr. Oaks. Please, as always, stay safe, stay healthy, keep on learning.